2010. In the virus blockada office in Belarus, Sergei Relasin was looking at a computer belonging to an Iranian customer that was caught in a reboot loop. His research team discovered that the computer was infected with a zero-day vulnerability. This discovery prompted researchers at the Semantic office in California to dig deeper into the worm, which targeted computers running the Windows operating system and spread to isolated computers through infected USBs or local area networks. Once the virus reached a victim computer, it would check if the infected computer ran the Simon Step 7 setup software. If it didn't, the worm quietly exited and left the computer alone. But if it did, the virus phoned home and reported information about the infected machines. And it also went ahead and downloaded more malicious files and kind of updated itself. The virus specifically targets programmable logic controllers or PLCs. These are used to achieve automation of electromechanical processes, commonly found in amusement park rides, assembly lines, and in nuclear plants, where they are used to control centrifuges to separate nuclear material. StuxNet is thought to be a targeted attack by the American and Israeli governments on the Iranian nuclear facility, but this is only speculation. The closest thing to a confirmation that we currently have is a vague statement by the former White House coordinator for arms control and WMDs. A botnet is a type of malware that is written with the intent of taking over a large number of hosts. Once infected, the compromised machines are under the control of a botmaster. The malicious user first builds the botnet or purchases it from a sketch website. It then starts infecting victims, and once infected, the victims become a part of the botnet. The bot master can then use his botnets to launch DDoS attacks, steal information, or for world domination.
So, what's a DDoS attack? In October of this year, many sites were hit by DDoS attacks. These companies included Spotify, Twitter, and Netflix, among others. A denial of service attack is one that makes a service, a network, or a machine unavailable to users. A distributed denial of service attack is where the attack uses multiple systems to cut off users from services. To understand how this attack happens, we first have to talk about zombies. Zombies are computers or botnets that have malware, trojans, or other malicious content on them that an attacker can use for his own purposes. Using these zombie computers or botnets, a master bot unleashes attacks that include a flood of SYN requests, a synchronized request which waits for an acknowledgement message for a connection that will never come, UDP attacks, DNS attacks, phishing attacks, and other purposes. Torpig was a malicious code that affected thousands of machines. It targeted sensitive information like passwords, credit cards, and bank account numbers. This was all done by something called mebroot. This malware was run at boot time, to ensure that it was undetected by victims. It attacked the master boot root, or MBR for short, which allowed it to pick what safety features were allowed to run. A research group at UC Santa Barbara overtook the Trojan for 10 days using their own command and control server, DNS, along with other preparations. During this time, they collected almost 70 gigabytes of data that included thousands of passwords, IP addresses, and credentials, among other things. The most affected computers were found in the US, then Italy, and then Spain. Most passwords were found in less than 2 hours with a password cracker named John the Ripper, or a simple password recovery. A lot of passwords were found simply because people reused them from another site.
And demo! To start off our demo, we actually used a virtual machine, which is a small partition on our hard drive, which kind of isolates the programs we're using here from our actual computer. It's a lot safer and it's a lot better to control.
To communicate with our master and pawn bots, we will need an IRC client. An IRC client is an internet relay chat client which allows text-based communication to take place. We set up the client already. We can see that it is IRC free node. We are now going to join the channel that we need to communicate to. As you can see, I'm going to just type in Nefarious here, which is our channel name, and we will have joined it.
We chose to use a IRC kit, which is basically a Python IRC library made by Charles Letter that's basically for demoing botnets. It's a really good documentation. It's found on readthedocs.io, and that's where we used it. And here you see we're just downloading basically the IRC kit and some dependencies. Here is a screen of both the master bot on the left and then the pawn bot on the right. And we're just basically showing you an overview of what's going on here.
We are now going to connect the master bot to the channel. We got the syntax from the documentation and formulated the command string. The program boss.py was already written for us. We are now going to authenticate it, and we saw that that was a success, and we asked for worker status and see that no workers are present.
Here's the pawn bot again. Innocent.py is basically just a file you would maybe download off the internet, but it actually contains some malicious code. So when you go ahead and run that, and you saw inside the file, it runs actually the worker named Pawnee, a worker bot named Pawnee.
The master bot actually got a notification that the worker was added to it. We're now going to try running different commands on the screen. So we start by running ls, and as you can see, it's going to print out everything that the pawn bot had saved in the system. We see something interesting, something maybe like confidential.py, and we're going to run it and try and see what's inside. We actually got all these passwords because the pawn bot saved all their passwords there. We're going to now run secretcodes.py, and what happened is that the pawn bot decided to save these complicated secret codes in a text file, and the master, the botnet, could actually see these text files and get the secret code out. We're now going to execute does not exist.py and see what happens. And as you can see, the pawn bot actually got a notification that this file wasn't found. What we're now going to try to do is try to open a web browser, and we're just going to say run Firefox.
After the command is run, you see on the right hand side, which is the pawn bot, Firefox ran. There goes my thumb of happiness. And here's a closer look of Firefox, so you kind of know what it looks like when it just opens on its own. Here, Facebook is being opened now via the master bot. And here you see that Facebook is now opened. I'm pretty excited here because it was very exciting to see one computer control another. Here we only demonstrated one botnet, but if you can imagine a multitude of them sending SYN requests, servers will be flooded and then taken offline. And this is pretty much what happens to a lot of DDoS server attacks.
So we're now going to talk about detecting botnets. If you notice that your computer fan is unusually noisy, if your computer crashes frequently, if shutdowns are slow, if you can't update antivirus or your OS, or if your browser is acting weird, you might have a botnet. We actually found this really cool website which lets you check if your computer is a part of a botnet network. This researcher has been mapping the known botnet networks, and you can actually check if your IP address is in. I haven't shown you the results because it actually displays my IP address, but mine wasn't a part of one.
Ways you can prevent yourself from getting a botnet is to turn on your firewall, use it, Use passwords that are secure. Don't use passwords again and again for different sites. Keep an updated antivirus. It's really, really important.
Now that we've explained what a botnet is, let us explain to you why we think it's cool. For us, it's mainly that there's no clear solution to the problem. There's no one technical answer that can just make botnets go away without being too much of an inconvenience to be feasible.